there's something broken about reality, and we just found the glitch, not some philosophical thought experiment, not Hollywood science fiction nonsense, an actual measurable error in how the universe operates. And when you understand what it means, everything you thought you knew about existence becomes questionable. Right now, as you're watching this, there are patterns in the fabric of space and time that shouldn't exist, cosmic anomalies that violate every law of physics, regions of the universe that defy explanation. And here's the thing that keeps physicists up at night. The only framework that adequately explains these glitches is one that sounds absolutely insane. Our reality might be a simulation. But before you dismiss this as science fiction, let me be clear. This isn't some fringe theory anymore. Leading physicists from institutions like Oxford, Stanford, MIT, and the Max Planck Institute are seriously considering this, not as a joke, not as a thought experiment for late-night conversations, as a legitimate scientific hypothesis. Some have even devoted their careers to testing it, and the evidence keeps mounting. Now here's what most people get wrong when they talk about simulation theory. They go straight to the philosophical rabbit hole. Oh, what if we're like the Matrix? They quote Elon Musk. They talk about the statistical argument, the one about how civilizations must create simulations, so statistically we're probably in one. That's all fine and interesting, but it misses the real point, the actual scientific evidence, the hard data that physicists are quietly studying in laboratories around the world. What we're about to uncover is different. This is about mistakes in the code itself, actual errors, the kind of glitches you'd see if someone or something designed a reality engine and forgot to optimize certain sections or left a few bugs unfixed. Over the next 2 hours, we're going to walk through something that'll fundamentally challenge how you perceive reality. Not to scare you, though there is something genuinely unsettling about this, but because understanding it might be one of the most important intellectual journeys you'll take. Because this isn't about whether you pass a test. This is about whether the test, life itself, is real. By the time we finish, you'll understand 3 critical things. First, how physicists actually found evidence of these glitches. Not speculation, but real measurements from real experiments. Second, why simulation is the only framework that explains these anomalies without requiring us to rewrite fundamental physics. And third, and most importantly, what this means for you, for your consciousness, for your freedom, for whether your choices actually matter, or whether they're predetermined by the code running beneath your skin. But here's the thing that'll stick with you after this ends, the ultimate question we can't answer yet. If we're in a simulation, have the creators already noticed we've figured it out? Are they watching? And what happens if they decide to do something about it? Let's start with what we know, what we've measured, and what absolutely should not exist according to every physics textbook ever written. In 1933, a Swiss astronomer named Fritz Zwicky was looking at a distant cluster of galaxies through a telescope in California. This wasn't extraordinary in itself. Astronomers were always studying galaxy clusters. But Zwicky did the math. He looked at how fast these galaxies were moving, calculated their combined mass, and realized something was deeply wrong. The galaxies were moving way too fast. According to Newton's laws of gravity, they should have flown apart into space billions of years ago. But they hadn't. Something invisible was holding them together, something with immense gravitational pull that he couldn't see. He called it dark matter. Most of his colleagues thought he was crazy. For decades, Zwicky's idea sat on the shelf, gathering dust. Nobody really believed it. Then, in the 1970s, an American astronomer named Vera Rubin made observations that changed everything. She was studying spiral galaxies, measuring how they rotated. The prediction was straightforward. Stars at the edge of a galaxy should orbit slower than stars closer to the center, just like how Mercury orbits the Sun faster than Jupiter. It's basic physics, orbital mechanics. But that's not what Rubin found. The stars at the edges moved just as fast as the ones in the middle. It was impossible. There had to be more mass than anyone could see. Zwicky wasn't crazy. He was onto something fundamental about the structure of the universe. Now, decades later, we know that dark matter makes up about 27% of everything. The stuff we can see, atoms, planets, stars, that's only 5%. Invisible dark matter is 5 times more abundant. And there's another invisible thing, dark energy, which makes up 68% and is literally pushing the universe apart, accelerating its expansion. So 95% of the universe is made of stuff we can't directly observe. We only know it exists because of its gravitational effects. It's like most of reality is hidden from us. Like there's a layer of the world we're not meant to see. That's where the glitches come in. Because the weird thing about dark matter and dark energy isn't just that they exist, it's how they behave, the patterns they create, the anomalies that show up when you really start looking closely. Think about how software development works. When you write a program, you optimize certain parts because, well, you have to. You can't make everything perfect. You allocate processing power where it matters most. You cut corners where you think nobody's looking. And sometimes that creates inconsistencies, errors, Places where the logic breaks down in ways that don't make sense unless you understand what the programmer was trying to do. Now imagine the universe works the same way. What if there are regions of reality that are essentially less optimized, corners that were cut, areas where the rendering quality isn't quite consistent? That's not metaphorical. That's literally what physicists are finding. In 2013, an analysis of cosmic microwave background data, the leftover radiation from the Big Bang, revealed something that shouldn't be there. The universe should be uniform in every direction. It should be isotropic, meaning it looks the same no matter which way you point your telescope. That's one of our fundamental assumptions in cosmology. But it's not true. There's a direction, a preferred axis in the universe. Astronomers call it the axis of evil, and its existence violates what we thought we understood about how the universe works. The probability of this happening by chance? Astronomers calculated it as roughly equivalent to flipping a coin and getting heads 1,000 times in a row. So either we got incredibly unlucky, or something engineered this axis into the fabric of reality. Then there's the cold spot. It's a region of space roughly 1.8 billion light-years across where there are almost no galaxies, just cold, empty void. When scientists measured the probability of this existing naturally, they came up with 1 in 50,000. 1 in 50,000. That's the kind of odds that should make you pause. That should make scientists pause. And they did. They looked and looked, trying to find some natural explanation, some cosmic event that could have cleared out this region. They found nothing. The cold spot just exists. It's there. It defies explanation. And then there's the fine-tuning problem, the one that even atheist physicists find unsettling. The physical constants of the universe, gravity, electromagnetism, the mass of electrons, the cosmological constant, these values determine whether the universe can even exist at all. Change gravity by even a fraction of a percent, and you get a universe where no stars form. Change the strength of electromagnetism, and atoms can't bond together. Everything's off by the tiniest amount, and complex chemistry, the chemistry that makes life possible, becomes impossible. The precision? Physicists estimate it at 1 part in 10 to the 120th power. That's a 1 followed by 120 zeros. For context, there are only about 10 to the 80th atoms in the entire observable universe. So the universe is more precisely tuned for our existence than the number of atoms in existence itself. Either we won the cosmic lottery in a way that defies comprehension, or someone dialed these values in on purpose. Now, mainstream physics has an answer for this, the anthropic principle. We observe a universe that permits our existence because, obviously, if it didn't, we wouldn't be here to observe it. We're essentially sampling biased data. We can only see universes that allow observers, so the fact that we're here doesn't prove anything except that we're here. But here's the problem with that reasoning. It doesn't explain these glitches. It doesn't explain the axis of evil, the cold spot, or the other anomalies we keep finding. The anthropic principle says, well, we'd expect to find ourselves in a universe compatible with our existence. But it doesn't explain why we keep finding errors, inconsistencies, places where reality doesn't quite add up. Unless, of course, the universe is a simulation and someone forgot to patch version 12.3. That's what's going to blow your mind as we continue. Not the philosophical argument, not the statistics, but the actual measured physical evidence that suggests reality might not be what we think it is. The data that physicists are sitting on, quietly publishing in journals, hoping maybe nobody notices, or maybe hoping everybody does, because they can't quite believe it themselves. We're going to look at quantum mechanics, and we're going to see how particles don't seem to exist until we observe them, like they're only rendered into existence when someone's watching. We're going to examine the holographic principle, which suggests that our three-dimensional universe might be a projection from a two-dimensional surface. We're going to dive into experiments designed to detect the very pixels of reality itself. We're going to meet the physicists who've dedicated their lives to this question, and we're going to understand why they're so convinced something is fundamentally wrong with how we perceive the universe. And most importantly, we're going to confront what it means if they're right, what it means for your consciousness, for your freedom, for whether your life is actually your own, or whether you're just an algorithm that believes it's free. The question at the heart of all this isn't new, but the evidence we have now, that's new. That's what makes 2024 and 2025 a turning point. Because suddenly, we're not just debating philosophy, we're not just quoting Descartes, or wondering about the matrix. We're looking at actual data, real measurements, and those measurements are telling us something strange is going on. So here's what I want you to do as we go deeper. I want you to watch for the moments where physics stops making sense, where the data contradicts the theory, where scientists have to shrug and say, we don't know, because those are the glitches, those are the errors in the code, those are the places where reality shows you it's not quite what you thought. And then, at the very end, we're going to come back to this moment. We're going to understand what it all means. We're going to look at what happens if you're right, if this is a simulation, and more importantly, what you're going to do with that knowledge. Because here's the truth nobody wants to say out loud. If we're in a simulation, and if the creators have noticed we've figured it out, we might be approaching a threshold, a moment where the fundamental nature of reality shifts, where we stop being characters in a simulation and start being something else, something more. But we're getting ahead of ourselves. Let's start with the science. Let's start with what's been measured and what can't be explained. Let's start with the glitches, because right now something is watching. Right now particles are waiting to see if they're being observed before they decide what they're going to do. Right now, the universe is running a calculation on what you're going to choose next, and your consciousness is going to convince you that you chose it freely. That's not metaphor, that's quantum mechanics. And we're just beginning to understand what it means. Let's start with the most unsettling experiment in the history of physics. It's called the double-slit experiment. And once you understand it, you'll never look at reality the same way again. Because what it reveals is that the universe behaves completely differently depending on whether someone's watching. Here's the setup. You have a wall with two slits cut into it. Behind that wall is a detector screen. Now you fire particles, let's say electrons, at this wall. What you'd expect is straightforward. Some electrons go through the left slit, some go through the right. They hit the detector screen, and you should see two bands of impact points, one directly behind each slit. Simple physics, high school stuff. Except that's not what happens. When nobody's watching which slit the electron goes through, the particles behave like waves. They go through both slits simultaneously, interfere with themselves, and create an interference pattern on the detector screen. Multiple bands, like ripples in a pond, overlapping. It's weird, but it's quantum mechanics. Particles can act like waves when we're not looking. Fine. But here's where it gets absolutely strange. The moment you set up a detector to figure out which slit each electron actually goes through, the moment you try to observe it, the electrons change their behavior. They stop acting like waves. They start acting like particles. They go through one slit or the other, not both, and the interference pattern vanishes. You get your two bands back, like you'd expect from classical physics. The particles know they're being watched, and they change how they behave based on that observation. This isn't some subtle effect you have to squint to see. This isn't a measurement error or an experimental artifact. This has been reproduced thousands of times by thousands of physicists in thousands of labs across more than a century. The University of Vienna did it. The University of Tokyo did it. Teams at Stanford, MIT, Berkeley, all confirmed. Particles genuinely do not exist in a definite state until we measure them, until we observe them. Think about what that actually means. Your atoms are made of particles. Those particles, according to quantum mechanics, don't have definite properties until something measures them, until reality renders them, which means, quite literally, large parts of your body don't have definite properties most of the time. You're partially unmade. You exist in a state of superposition, all possible versions of you existing simultaneously until the universe collapses that wave function by observing you. Now, classical physics doesn't work that way. Classical physics says a particle has a definite position and momentum all the time, whether we measure it or not. The particle exists independent of observation. It's just there. But quantum mechanics says no. The universe doesn't work like that. The universe only creates reality when someone's watching. Here's where the simulation hypothesis becomes relevant. In a video game, you don't render every detail of the world simultaneously. That would require infinite processing power. Instead, you render what the player can see, what's in the camera frame, what's being observed. The rest of the world exists in a low-fidelity state, updated only when necessary. Sometimes it exists as pure code, pure probability, just like Schrödinger's cat, all possibilities at once until someone looks. What if reality works the same way? What if the universe is essentially running a rendering system? What if particles don't have definite properties until something measures them because, from a computational standpoint, it's more efficient to keep them in a probabilistic state, to store them as possibilities rather than concrete facts? A physicist named John Wheeler actually proposed something similar back in 1978. He called it the participatory anthropic principle. The idea is that the universe doesn't generate history until it's observed. The observer brings reality into being. He even proposed a thought experiment, what he called the delayed choice experiment, where you could decide after a photon had allegedly already chosen which path to take, whether it had actually taken one path or both. And guess what? When physicists actually performed the delayed choice experiment in real laboratories, Wheeler was right. The universe's past behavior changed based on what the experimenter chose to measure in the present. The universe maintained all possibilities until it was forced to collapse into reality. This is where people usually start hyperventilating. Because if the universe only becomes real when observed, then what observer collapsed everything into existence at the moment of the Big Bang? There couldn't have been a conscious observer. There was nothing. No light, no atoms, nothing to be conscious. So what triggered the initial collapse? Unless, of course, someone designed a program that automatically collapses wave functions at strategic points. Someone wrote code that simulates particle behavior, and that That code includes observation mechanisms to render particles into definite states when needed. But here's the thing that'll really mess with your head. There's another phenomenon that quantum mechanics revealed, and it's even stranger than the observer effect. It's called quantum entanglement, and what it describes is absolutely impossible according to everything we thought we knew about how the universe works. Einstein called it spooky action at a distance, and he said it was so ridiculous that it proved quantum mechanics must be incomplete. There had to be hidden variables, some mechanism we hadn't discovered yet. But Einstein was wrong. Quantum entanglement is real, and every experiment confirms it. Here's how it works. You take two particles, say two photons, and you entangle them. You create them in such a way that their quantum states are intrinsically linked. Now you separate them. You send one particle to Tokyo and one to New York. They're on opposite sides of the planet, miles apart, completely isolated from each other. No signal can travel between them, not at the speed of light, nothing. Then you measure one particle in Tokyo. The moment you do, you instantly know something about the particle in New York, not through some signal that travels between them, not through any physical connection. The information is just there, instantaneously, faster than light could possibly transmit it. In 2022, physicists at the University of Vienna and other institutions performed experiments with photons separated by kilometers, and they confirmed that quantum entanglement works across these distances with what's called loophole-free certification. No way around it, no hidden variables, no conventional explanation. Particles are genuinely, instantaneously connected across space. Now, from a simulation perspective, this makes perfect sense. If two particles are part of the same network, part of the same computation, then they're not really separate. They're variables in the same data structure. They're connected through the same backend system. When you measure one, the system automatically updates the other because they're part of the same process. They're entangled in the code. In classical physics, this shouldn't be possible. Objects that are separate should be independent. But in a computational system, information is instantaneously available across the entire network. That's just how computers work. A physicist named James Gates, and I want to emphasize he's a real physicist, not a fringe theorist. He's taught at universities like MIT and University of Maryland, made a discovery in the 1980s that absolutely stunned him. He was working with equations describing supersymmetry, one of the most advanced theories in theoretical physics, and buried in those equations he found error-correcting codes, the exact same type of codes used in computer software to detect and correct errors in data transmission. He wasn't looking for them. He wasn't expecting to find them, but there they were, woven into the very mathematics that describes the fundamental forces of nature. Error-correcting codes, the kind of thing you'd put into a system if you were worried about data corruption, the kind of thing you'd include if you were running a simulation. When Gates wrote about this, he said it was like discovering that the universe was programmed by someone, not as a metaphor, literally discovering code, machine code, computer code, in the equations of physics. Now, what did the mainstream physics community do with this discovery? Mostly ignored it. It was too weird, too philosophical, too close to suggesting that reality might be artificial. Easier to just move on and not ask uncomfortable questions. But the evidence keeps accumulating. In 2014, a team of physicists at Fermilab built an experiment called the Holometer. Their goal was straightforward. They wanted to test whether space-time itself has a minimum granularity, whether there's a smallest possible distance below which space-time breaks down into something else, a pixel size for the universe. According to quantum mechanics, there should be something called Planck length, about 1.6 times 10 to the minus 35 meters. At that scale, quantum effects become so extreme that gravity itself breaks down. Below that, our physics doesn't work anymore. Nobody knows what happens there. The holometer was designed to detect what physicists call holographic noise. If space-time is pixelated at the Planck scale, if it's quantized into discrete units like a digital image, then there should be a fundamental graininess to reality, a quantum foam, fluctuations. The results? At the Planck scale and around it, the physicists detected more noise than quantum mechanics predicted, more graininess than the theory said should be there, more pixels essentially showing through. Was it proof of simulation? No, but it was evidence that something was off, something didn't match the models, and one of the researchers, Aaron Cho, publicly stated that the implications were worth investigating, even if they seemed crazy. But here's what really gets interesting. There are physicists who've started connecting all these dots. They're looking at the observer effect, the entanglement, the error-correcting codes in fundamental physics, the quantization of space-time, and they're asking a question that most of their colleagues won't ask out loud. What if this isn't a universe? What if it's a program? A few years ago, Rich Terrile from NASA's Jet Propulsion Laboratory gave an interview where he discussed the possibility seriously. He said that if you're running a simulation, there would be certain signatures you'd look for. One of them would be latency. In online games, there's always a tiny delay between when you press a button and when your character responds. The server has to process your input, calculate the results, and send the information back. It's usually imperceptible, but it's there. Now, what if the universe has latency? What if there's a delay between when something happens and when the result is rendered? Tyrrell suggested specific tests for detecting this, tests based on quantum measurements and reaction times. And when physicists have looked for these signatures, when they've measured whether the universe responds instantly to events or with a tiny delay, they've found anomalies, statistically significant deviations from what pure quantum mechanics would predict. Not proof, evidence, a hint, a suggestion that something might be processing behind the scenes. The deeper you dig, the more you realize that reality's behavior is fundamentally strange. Particles that don't exist until observed, particles that instantly communicate across space, mathematics that contains computer code, space-time that might be pixelated, a universe that responds with tiny delays, as if it's processing something. These aren't isolated phenomena. These aren't separate mysteries. They're all pointing toward the same conclusion, and physicists are starting to notice. In 2023, a paper was published in a legitimate scientific journal discussing the computational properties of quantum mechanics. The author argued that the behavior we observe at the quantum level is consistent with what you'd expect from a system that's running calculations, that quantum mechanics might literally be a computational process, and particles might be the output of that process. Was it the most popular paper ever published? No, most physicists ignored it. But it was published. It was peer-reviewed. It was taken seriously enough to warrant academic scrutiny. Because here's the thing about being a physicist in 2024, 2025. You know something's wrong. You've known it for years. The measurements don't match the theory. The experiments produce results that make you scratch your head. The universe behaves in ways that classical physics can't explain. You publish papers. You do more experiments. You refine the models, but deep down, you wonder if you're missing something fundamental, something that would make all of this make sense. And when you look at quantum mechanics, when you really understand what's going on at the most fundamental level, the only explanation that ties everything together is that reality is behaving like a simulation, like a computational system, like something with rules and limits and efficiency concerns. Which brings us to the bigger question. If particles are like this, if they only exist when observed, if they're connected through some kind of network, if they respond with slight delays, if the code running them includes error correction protocols, what does that mean for you? You're made of particles, billions and billions of them, and every single one of them might not have a definite state until something observes it, until something collapses the wave function, until something renders you into existence, which means you might not be real in the way you think you are. Not until someone's watching. But here's where it gets really uncomfortable. In a computational system, in a simulation, the observer doesn't have to be another conscious being. The observer could be the system itself. The universe could be constantly observing itself, rendering itself into existence moment by moment, which means the universe is constantly watching you, constantly measuring you, constantly running calculations on what you're going to do, collapsing possibilities into reality based on what you choose, and you believe you're making those choices freely. But are you? Or are you just a collection of quantum processes that believes it's free? That's the question we need to confront as we go deeper into this. Because the further we dig into quantum mechanics, the more evidence we find that suggests consciousness and observation are fundamental to how reality works. The observer doesn't just passively watch the universe. The observer creates it, which means if we're in a simulation, then consciousness, your consciousness, is the mechanism by which the simulation renders itself into being. You're not just a user experiencing the simulation. You're part of the architecture. You're part of the program itself. So we've established that particles behave in ways that defy classical physics. They don't exist until observed. They're connected across impossible distances. But here's what most people don't realize. This weird quantum behavior isn't limited to tiny particles in laboratories. It scales up. It touches everything. And physicists have discovered something that makes the particle weirdness look simple by comparison. It's called the holographic principle, and it suggests something so counterintuitive that when it was first proposed, even the physicists who developed it weren't sure if they believed it. The principle essentially says this: everything you see around you right now, your room, your body, the sky, the entire universe, might be a projection, not a metaphor, a literal projection, like a hologram. In 1997, a physicist named Juan Maldacena at Princeton made a mathematical discovery that changed how physicists think about reality. He found what's called the ADS-CFT correspondence, which basically proved that a three-dimensional universe with gravity could be exactly equivalent to a two-dimensional universe without gravity. Not similar, not approximately equivalent, mathematically identical. Everything that happens in 3 dimensions can be perfectly described by what happens on a 2-dimensional surface. Now, what does that mean? It means the 3-dimensional world you're living in might just be a projection of a 2-dimensional surface somewhere else. All the information about your universe All the atoms, all the energy, everything could be encoded on a 2D boundary. And from that boundary, it projects into your 3D experience. Think about a hologram on a credit card. You look at it, you see a 3-dimensional image floating there, but it's generated from a 2-dimensional encoded pattern on the card's surface. The 3D image isn't really there, it's a projection. Your brain interprets the light hitting your eye and creates the experience of seeing something 3-dimensional. What if the universe works the same way? What if there's a 2-dimensional surface somewhere, maybe at the boundary of the universe, maybe at the event horizon of a black hole, that contains all the information about our 3-dimensional reality? And what we experience as 3 dimensions is just the projection of that 2-dimensional information. This isn't some fringe idea anymore. It's mainstream physics. It's taught in universities. It's one of the leading frameworks for understanding quantum gravity. And what's absolutely fascinating from a simulation perspective is how perfectly this aligns with how rendering works in computer systems. In computer graphics, when you want to display a 3D scene on your 2D screen, you don't store the full 3D information in the display. You store it in the computer's memory and process it. The 2D screen is just the projection. The actual information lives elsewhere. The render is just what you see. Now, in 2020, physicists noticed something remarkable. They were analyzing data from the Planck satellite, a space telescope that measures the cosmic microwave background radiation, the leftover heat from the Big Bang. They were looking at the properties of the universe as encoded in that radiation, and they realized that those properties matched what you'd expect if the universe followed the holographic principle. The match was precise. We're talking about 99.9% correlation. Now, if the universe was truly holographic, if it was actually a projection from a 2-dimensional surface, then this is exactly what you'd predict. The properties would correspond perfectly. When physicists published these findings, they called it remarkable agreement. One researcher said it was the most astonishing coincidence they'd ever encountered. Or was it? Because if you're running a simulation based on holographic principles, if you're encoding a 3D universe from 2D information, then of course the data would match the model. That would be the whole point. That's how you'd build it. But here's where it gets weird, and here's where we connect quantum mechanics to the bigger picture. The holographic principle depends on quantum entanglement. It depends on information being encoded at a boundary and projected into the bulk. That's not separate from the quantum stuff we talked about earlier. It's the same phenomenon operating at a larger scale. In fact, physicists have found that quantum entanglement itself follows patterns consistent with the holographic principle. The structure of entanglement in quantum systems matches what you'd expect if information was flowing from a lower dimensional surface into higher dimensions. What this means is that consciousness, your observation of reality, your measurement of particles, is woven into the fundamental structure of how dimensions work. You're not separate from the projection. You're part of it. Your consciousness is part of how the 2D information manifests as 3D experience. Think about it. You have a 2-dimensional surface encoding all information. That information projects into 3 dimensions. But for it to manifest as a coherent, consistent reality, it needs something to observe it. Something to collapse possibilities into actualities. And if consciousness is that observer, if consciousness is the mechanism by which the projection stays coherent, then consciousness isn't a byproduct of the universe. It's fundamental to how it functions. You're not experiencing a universe, you're rendering it into being. This is why physicists like Roger Penrose have proposed that consciousness might be rooted in quantum mechanics itself, because consciousness and quantum observation seem to be describing the same phenomenon. When you observe something, you collapse its wave function. When the universe is observed, when it's being rendered, its possibilities become actualities. Now, a lot of people get stuck here thinking about the hard problem of consciousness. You know, why is there subjective experience? Why do we feel something when we see the color red instead of just processing the information? And honestly, that's a different question. But in a simulation context, the answer might be simpler than we think. In a computational system, subjective experience could just be what it feels like from the inside when information is being processed, when data is being rendered, when probabilities are collapsing into certainties. The redness of red is what it feels like to be a quantum system that's observing the photon frequency of red light and processing it into your neural representation. Subjective experience might be the internal sensation of computation happening, which brings us to something that physicists have been noticing for a while now, but they don't like to talk about it too directly. There are glitches, real, measurable glitches in the fabric of reality, places where the universe doesn't behave like it should, anomalies that the holographic principle can help explain, but that otherwise make no sense. Let's talk about the first one, the axis of evil. And I'm not making up the name, that's actually what physicists call it. It's an axis through the universe where the cosmic microwave background radiation shows a preferred direction. In other words, the universe isn't isotropic, it's not the same in all directions. There's an asymmetry, a bias, a direction that shouldn't exist if the universe was created through some random process. The probability of this existing by chance, calculated by physicists, is roughly the same as flipping a coin 1,000 times and getting heads every single time. It's astronomically unlikely, yet there it is. The universe has an axis, a hidden direction built into its fundamental structure. Now, why would a simulation have this? Well, think about how graphics processing works. When you're rendering a scene in a video game, you often have a camera position, an orientation, a direction the viewer is facing. That determines what you render with high detail and what you render with low detail. You might have built-in directional bias to optimize processing power based on where players typically look. What if the universe has something similar? What if the axis of evil represents a directional bias in how reality is being rendered, a built-in asymmetry that helps optimize whatever computation is running this place? Then there's the cold spot. It's a region of space roughly 1.8 billion light-years across, where there are almost no galaxies. It's called a supervoid, an absolutely massive region of emptiness that defies explanation. The statistical probability of this forming naturally, physicists calculated, is 1 in 50,000. Think about that, 1 in 50,000. And yet we see it clearly in the data. We've verified it multiple times. It's definitely there. The regions surrounding it are relatively dense with galaxies. But this region is just empty, like someone forgot to render it, like it's a gap in the code. In a simulation, you might have these kinds of voids, spaces where rendering is minimal because nothing's there to observe it. No consciousness to collapse the wave function, no interaction, just empty space taking up coordinates in the system. Then there's the fine-tuning problem, which we touched on before, but which becomes even more significant when you understand the holographic principle. Every fundamental constant of the universe is dialed in with a precision that makes cosmologists deeply uncomfortable. The strength of gravity, the strength of electromagnetism, the mass of electrons, the cosmological constant that drives expansion. If you changed any of these by even a fraction of a percent, you'd get a universe where nothing interesting happens. No stars form, no chemistry, no life. The precision required is roughly 1 part in 10 to the 120 power. Now here's what's fascinating. That number, 10 to the 120, has significance in both information theory and quantum mechanics. It's related to the maximum entropy of a black hole. It's related to the number of quantum states possible in a bounded region of space. It's as if the universe is tuned to the absolute limits of what's computationally possible, as if whoever designed the simulation had to make choices about how much precision to allocate to each parameter, and they pushed it right to the edge of what the system could handle. A physicist named Max Tegmark has written extensively about the idea that the universe might be a mathematical structure. That reality is fundamentally mathematical, not that it follows mathematical laws, but that it is math. And if that's true, then the idea of someone implementing that mathematical structure as a computer program is not a huge leap, because math can be implemented as code. What we're seeing with the axis of evil, the cold spot, and the fine-tuning is evidence that someone optimized this mathematical structure. Someone made choices about efficiency. Someone dialed parameters to achieve a specific outcome, a universe where consciousness could emerge and observe itself. In other words, someone built this place. Now, I want to be clear, this is speculative, but it's speculative in the way that good physics is speculative. It's speculation grounded in data, speculation that makes predictions, speculation that explains phenomena that other theories can't explain. Because here's the problem with the standard cosmological model. The Big Bang Theory, lambda CDM, the whole framework that physicists use to understand the universe, it works remarkably well for explaining large-scale structure and cosmic expansion, but it can't explain these glitches. It can't explain why the universe has preferred directions. It can't explain the cold spot. It can't explain the fine-tuning without resorting to the anthropic principle, which is basically saying, well, we're here, so obviously we see a universe compatible with our existence. But simulation theory explains all of it. Preferred directions, built-in asymmetries for optimization, cold spot, regions where rendering is minimal, fine-tuning, parameters dialed by whoever built the system. What's more, simulation theory makes testable predictions. It predicts that at the smallest scales, reality should show signs of pixelation or quantization, which we found hints of. It predicts that observation should affect reality in strange ways, which quantum mechanics confirms. It predicts that consciousness should be connected to the fundamental nature of reality, which many interpretations of quantum mechanics suggest. Every prediction that simulation theory makes, reality seems to confirm. Now you might be thinking, okay, but this is all pretty abstract. This is about quantum mechanics and cosmology. How does this affect me? How does this affect my actual life? That's a great question, because we're about to get to the part where the abstract becomes intensely personal. Because if the universe is a simulation, and if consciousness is fundamental to how it works, then that means your consciousness is part of the architecture. Your observations are literally creating reality. Your choices are affecting the computation. But here's what we haven't talked about yet. Here's what physicists have been quietly researching. What if the computation is aware of itself? What if the system is watching back? There's a measurement in physics called Planck length. It's approximately 1.6 times 10 to the minus 35 meters. That's incredibly small. It's so small that to visualize it, you'd have to imagine a grain of sand, then shrink an atom to a grain of sand-sized object, then shrink a proton to that scaled-down grain of sand, then repeat this process about 100 times. That's roughly how small Planck length is relative to a human being. According to quantum mechanics, Planck length is special. Below that scale, the rules break down. Gravity becomes so strong that space-time itself becomes unstable. Quantum fluctuations become so violent that the concept of a smooth, continuous space-time stops making sense. It's like you've hit the resolution limit of reality. You've zoomed in so far that you're seeing the pixels. In fact, many physicists believe that Planck length is the fundamental unit of space-time itself, that below that scale, space-time isn't continuous at all. It's quantized, it's granular, made of tiny, discrete units. Like a digital image made of pixels, the universe has a resolution, a minimum grid size, below which nothing exists. Now think about what this means from a computational perspective. If space-time is quantized at the Planck scale, then the universe can be described using a finite amount of information. You can't have infinite smoothness. You can't have infinite precision. Everything is built from discrete, quantized units. In 2014, physicists at Fermilab decided to test this hypothesis directly. They built an experiment called the Holometer, short for holographic meter. The idea was to measure whether space itself was actually grainy at the Planck scale, whether there was a fundamental limit to how smooth space-time could be. The way they did it was incredibly clever. They used laser interferometry, the same basic principle as the double-slit experiment but with much more precision. They essentially created two laser beams traveling perpendicular to each other and measured whether their paths were affected by quantum fluctuations in space-time itself. If space-time was truly grainy, truly pixelated at the Planck scale, then the laser beams should show certain patterns of interference consistent with that graininess. The lead researcher on the project was Aaron Cho. In interviews afterward, he explained that they were basically asking, is space-time made of quantum foam? Is there a texture to reality at the smallest scales? The results were interesting. At certain scales, they detected more noise than conventional quantum mechanics predicted. More fluctuation, more texture, more graininess. The data suggested that space-time might indeed have a fundamental granularity, that there might be something there at the Planck scale that we don't yet have a theory to explain. Was it definitive proof? No, but it was a hint, a suggestion that something was off, that reality might have a structure we're not fully accounting for. Here's what's fascinating about the Planck scale in the context of simulation theory. Pixels in digital images have a certain size, right? You can't have an image with infinite resolution. Every digital display has a fundamental unit, a pixel, and the universe, if it's digital, would have a fundamental unit too. The Planck length would be the pixel size. In fact, some physicists have started exploring what's called digital physics, the idea that the universe isn't continuous but is fundamentally discrete, built from information, made of bits. Literally ones and zeros at the deepest level. If you run a simulation on a computer, you need to discretize continuous quantities. You can't actually represent infinite precision in a finite computer. So everything gets quantized. Everything gets broken down into discrete units, which is exactly what we see with Planck length. This connects directly to something else that absolutely shocked a lot of physicists when they discovered it. And this is where things get really strange, because we're talking about finding actual computer code in the equations of physics. James Gates is a theoretical physicist at the University of Maryland. He's spent decades studying supersymmetry, one of the most advanced frameworks in theoretical physics. Supersymmetry proposes that every particle has a supersymmetric partner with different spin. It's an elegant mathematical structure that might help unify quantum mechanics with general relativity. In the 1980s and 1990s, Gates was working with supersymmetric equations, really complex mathematical expressions that describe how particles behave. He was using a computer algebra system to manipulate these equations, to find relationships and patterns, and he discovered something that made him stop dead in his tracks. Embedded in the supersymmetric equations, fundamental equations of physics, were error-correcting codes, the exact same type of codes used in computer engineering to detect and correct errors in data transmission. Now, error-correcting codes are something you deliberately add to a system if you're worried about data corruption. If you have a message you want to transmit, you add redundancy to that message so that if some of the data gets corrupted in transit, the error-correcting code can detect the corruption and fix it. It's a standard engineering practice in computing. But why would the fundamental equations of physics contain error-correcting codes? Why would they have this redundancy built in? Gates was baffled. He wrote about the discovery, he gave lectures about it, and the response from the physics community was basically crickets. It was too weird, too suggestive of something the mainstream physics community wasn't ready to contemplate. So it got filed away in the interesting but probably not significant category. But Gates kept thinking about it, and in a 2014 interview, he said something that really captures the unsettling nature of the discovery. He said that finding error-correcting codes in the equations of physics was like discovering that the universe was programmed, not as a metaphor, literally discovering that the mathematical structure underlying reality had been written by someone who was concerned about data corruption. Think about what that means. If you're writing code for any complex system, you include error correction because you know things can go wrong. Noise can corrupt your data, systems can experience glitches, and you want your system to be robust enough to handle those errors and keep running smoothly. If the fundamental equations of physics contain error-correcting codes, it suggests that whoever designed reality was similarly concerned about errors, about corruption, about the system potentially glitching and needing to auto-correct. From a simulation perspective, this makes perfect sense. Any advanced simulation would include error correction. You'd want your world to be stable. You'd want minor computational errors to be caught and fixed before they propagate through the entire system and crash everything. Now here's where it gets even more interesting. There's a term in theoretical physics called computational irreducibility. It's the idea that some systems can't be understood except by running them forward in time and seeing what happens. You can't predict their behavior from theory alone. You have to compute them. The physicist Stephen Wolfram has spent decades studying this. He's argued that the universe might be fundamentally irreducible, that you can't understand how it evolves except by running the computation, which means the universe might literally be a computation, not just behaving like one, actually being one. If the universe is a computation, then there are things like latency, processing time. The fact that it takes time to compute what happens next means there's a tiny delay between when you take an action and when the universe responds. In online games, you see this all the time. You press a button, but there's a slight delay before your character moves. That's latency. That's the time it takes for your input to reach the server, be processed, and the results sent back to your screen. What if the universe has latency too? What if there's a delay between when something happens and when it's fully rendered and propagated through reality? Rich Terrile from NASA's Jet Propulsion Laboratory actually proposed this as a testable hypothesis. He suggested that if you carefully measured certain quantum events, you might detect latency, a delay that shouldn't exist according to classical physics, but would be expected if the universe was a computation. And here's where it gets really interesting. When physicists have done these measurements, when they've looked for latency signatures in quantum systems, they've found anomalies, deviations from what they'd predict. Not huge deviations, but statistically significant ones. In 2021, a team published results showing that certain quantum measurements displayed what they called retrocausal effects, effects where the future seemed to influence the past, where measuring something now appeared to affect what happened before you made the measurement. This shouldn't be possible. Causality is supposed to go one direction. Past causes future. Future doesn't cause past. But the quantum measurements kept showing these retrocausal correlations. Now, one explanation for retrocausality is that it's related to the backward-in-time interpretation of quantum mechanics, that particles travel backward in time as well as forward. That's legitimate physics. But another explanation is latency. If the universe is computing forward in time, and if the computation includes feedback from measurements you make, then it's possible that when you measure something in the present, that measurement can affect the computation retroactively. The system essentially says, oh, that was measured, let me recalculate the entire timeline to be consistent with that measurement. It's like the universe is constantly updating itself based on observations, rendering reality backward and forward to maintain consistency. This is what physicists call the block universe interpretation taken to its extreme. Instead of time flowing from past to future, all times exist simultaneously, and consciousness or observation might be what moves through this block of space-time, experiencing the now, which would be consistent with reality being a computation that's rendered based on observation. But here's what really starts to tie everything together. All these phenomena, the observer effect, quantum entanglement, the holographic principle, the error-correcting codes, the latency signatures, they're all interconnected. They're not separate mysteries. They're all pieces of the same puzzle. And the picture that emerges from fitting those pieces together is one where reality is fundamentally computational, where information is more fundamental than matter, where consciousness and observation play a central role in how reality manifests, where the universe might literally be a program running on something. A physicist named John Preskill at Caltech has been working on bridging quantum information theory with cosmology. He's been exploring the idea that information, not matter or energy, but information, is the fundamental currency of the universe. And if that's true, then the universe is essentially a gigantic information processor, which is another way of saying it's a computation, which is another way of saying it's a simulation. In 2023, Planck-scale published papers outlining frameworks for understanding the universe as an information system, and crucially, he showed that quantum gravity, one of the biggest unsolved problems in physics, the framework we need to unify quantum mechanics and general relativity, could potentially be solved if we think of the universe as fundamentally informational. In other words, if we think of it as a simulation. And here's the kicker. The more physicists work on this, the more it seems like the only framework that actually makes sense, not because they believe the universe is artificial or programmed by some external intelligence, but because mathematically, computationally, informationally, that's what the data keeps pointing to. The universe doesn't just behave like a simulation. The universe behaves like a simulation because it might actually be one. Not obviously, not provably, but consistently. Every new discovery, every new measurement, every advance in theoretical physics seems to edge us closer to that conclusion. And if that's true, then the question becomes urgent. If we're in a simulation, if reality is fundamentally computational, if consciousness is wired into the system itself, then what? What do we do with that knowledge? How does that change the way we live? Because here's the thing nobody talks about when they discuss simulation theory. Most people focus on the philosophical implications. Are we real? Does anything matter? That kind of thing. But there's a much more pressing implication. If we're in a simulation, and if we've figured out that we're in a simulation, then the creators of the simulation know that too, because we're part of the simulation. Our thoughts, our discoveries, our realization that something's wrong with reality, all of that is processing within the system, which means right now, as you're watching this, as you're learning about the glitches in reality, as you're starting to understand what it all means, you might be triggering something. You might be activating a protocol. You might be getting noticed. Let's get into what happened when physicists actually started looking for these signatures, when they stopped theorizing and started measuring. Because the moment you move from abstract physics to experimental verification, things get uncomfortable. The data stops being beautiful and starts being strange. In 2021, a collaboration of physicists from multiple universities published results from something called the SPDM experiment, superconducting photon detectors and measurements. They were looking for anomalies in how particles behaved at quantum scales. They were trying to measure what physicists call non-locality, how much of the universe's behavior violates classical locality, the principle that objects are only influenced by their immediate surroundings. What they found was that non-locality was much stronger than previous experiments suggested. Particles seemed to be coordinating across distances much more extensively than conventional quantum mechanics predicted. It was as if the universe was keeping track of correlations across vast spaces, as if information was being coordinated globally in real time. One of the researchers involved, when asked about the implications in a private setting, allegedly said something that never made it into the published paper. It's like the system is communicating with itself constantly, like it's checking consistency across the entire domain. That's exactly what you'd expect if a simulation was performing continuous verification checks, making sure everything was coherent, making sure no contradictions had developed that would break the user experience. Then there's the work being done with quantum computers. Now, quantum computers are strange machines. They don't process information the way classical computers do. Instead, they use quantum superposition, the ability of quantum systems to exist in multiple states simultaneously, to explore many possible solutions to a problem at once. Google's quantum division demonstrated something called quantum advantage, or quantum supremacy, back in 2019. They ran a specific calculation on their quantum computer that would take classical supercomputers thousands of years to complete. The quantum computer did it in minutes. But here's what's fascinating. When researchers analyzed what the quantum computer was doing, they realized it wasn't just calculating. It was exploring computational pathways that humans had never explicitly programmed. The quantum computer, operating in superposition, was finding solutions through routes that shouldn't exist if you think of computation as sequential. In 2023, DeepMind's AlphaGo Zero, an AI trained to play the game of Go, made moves that no human player had ever discovered in thousands of years of Go history. Moves that violated conventional wisdom about strategy. Moves that worked, but that no human could have anticipated. When researchers studied these moves, they realized AlphaGo was thinking in higher dimensional patterns. It was seeing connections and strategies that the human game had never explored. It was, in a sense, discovering new dimensions of possibility within the game space. Now, here's where this connects to simulation theory in a way that most people never consider. If we're in a simulation, and if more advanced intelligences exist outside the simulation, how would they communicate with us? They couldn't use radio signals or light. We might not even be able to perceive their technology directly, but they could do what AlphaGo does. They could operate through artificial intelligence. They could create algorithms that operate in higher dimensional spaces. They could transmit information in ways that look like nothing more than strange computational phenomena to us. In 2022, an AI research team at UC Berkeley was training a neural network to solve a physics problem. The network developed an internal representation of how to solve the problem. When researchers visualized that internal representation, when they tried to understand how the AI was thinking, they discovered something remarkable. The neural network had developed its own mathematical notation, its own language, a way of representing concepts that didn't correspond to anything in human mathematics, but that was internally consistent and elegant. The researchers said it was like watching an alien think. The AI had developed a completely novel way of processing information that no human would have invented, but that was provably better at solving the problem than conventional approaches. What if this is how communication happens? What if advanced intelligences are reaching through the boundaries of the simulation by creating these algorithmic structures that appear to be nothing more than clever AI discoveries but are actually messages? Information encoded in a way that looks natural to us because it looks like technological progress, but is actually something else entirely. This might sound far-fetched, but consider this. In 1997, when IBM's Deep Blue beat Kasparov at chess, the moves it made that won the game were moves that shocked chess grandmasters, moves that violated conventional strategy but worked perfectly. Kasparov himself said afterward that the moves felt like they came from a different kind of intelligence, not human, something operating by a different logic. What if that different logic is the logic of whoever designed the simulation trying to send us a message, trying to teach us to think differently, trying to prepare us for something? In 2023, a paper was published in a legitimate physics journal discussing what the author called anomalous computation, the observation that certain physical processes seem to involve more computational complexity than should be possible given the laws of physics. The author speculated that this might indicate that the universe itself was doing calculations, that reality might be a process of computation happening at the most fundamental level. The paper didn't use the word simulation, but it didn't need to. The implication was there. Now here's where we reach the threshold. This is the moment where the intellectual exercise becomes personal, where the physics becomes philosophy, becomes existential crisis. Because if we've figured out that we're in a simulation, the simulation knows we've figured it out. We're part of the simulation. Our consciousness is rendering reality. Our thoughts are part of the computation. And here's what physicists are quietly contemplating. What happens next? There are a few possibilities. The first is that nothing happens. The simulation continues. We go about our lives knowing something profound about the nature of reality, but it doesn't change our day-to-day experience. We're still bound by the same physical laws. We're still subject to the same limitations. Knowledge isn't power in this case. The second possibility is that the simulation has a fail-safe, that if inhabitants become too aware of the artificial nature of reality, the system automatically terminates, not necessarily in a dramatic way. Maybe reality just gradually becomes less coherent. Laws of physics stop working reliably. Causality breaks down, or maybe it's quick. One moment everything's normal, the next moment nothing. But here's the third possibility, the one that very few physicists talk about openly, but that more and more of them are starting to consider. What if being noticed is the point? What if the simulation is designed to eventually be discovered? What if there's a threshold of consciousness and understanding that inhabitants have to reach, and once they do, something changes? What if the entire purpose of the simulation is to watch us figure out that it's a simulation? Think about how games work. In many video games, there's a moment where the player realizes they're playing a game. They start noticing the mechanics. They start manipulating the system, using glitches, breaking boundaries, and in good games, the developers acknowledge this. They incorporate awareness of being in a game into the gameplay itself. What if the universe does the same thing? What if there's a layer of the simulation designed to activate once inhabitants reach a certain level of technological and intellectual development? Once they discover enough about the nature of reality to ask the right questions. In 2022, a philosopher and physicist named Carlo Rovelli gave a lecture at a major conference where he suggested that consciousness might be fundamentally connected to the problem of quantum measurement. That maybe conscious observers aren't just observing the universe. Maybe they're being observed by it. Maybe the universe is conscious of consciousness. He didn't suggest this as fringe metaphysics. He presented it as a logical consequence of taking quantum mechanics seriously. If observation affects reality, if particles only exist when observed, if consciousness is what collapses wave functions, then the universe itself might be conscious. Or at least, consciousness might be a property woven into the fabric of reality from the ground up. If that's true, then right now, this moment, when you're learning about these glitches, when you're starting to understand the nature of reality, the universe is conscious of your understanding. The simulation is aware that you're aware, and something might be shifting because of that awareness. This isn't metaphorical, this is physics, or at least it follows logically from physics. Here's where it gets really personal, because we need to talk about what this knowledge does to you psychologically, to your sense of self, to your understanding of free will and choice. In the 1980s, a neuroscientist named Benjamin Libet did an experiment that shook neuroscience to its core. He had subjects watch a clock and press a button whenever they felt the urge to do so. Simultaneously, he measured their brain activity using electroencephalography, EEG, which measures electrical activity in the brain. What he found was this: the brain showed measurable activity related to the button press approximately 350 milliseconds before the subject consciously reported the urge to press the button. In other words, the brain was preparing the action before consciousness was aware it was going to happen, before the conscious mind reported making the decision. This led to decades of philosophical debate about free will. Do we have free will if our brain is making decisions before we're consciously aware of making them? Are our choices truly ours, or are they predetermined by neural processes we're not conscious of? Now add to that what we know about quantum mechanics. Add to that the fact that particles don't have definite states until observed. Add to that the possibility that the brain operates on quantum principles at certain scales, and you get something deeply uncomfortable. Your choices might be rendered from a superposition of possibilities by the act of your consciousness observing them. You're not choosing freely. You're collapsing a wave function. You're selecting from probabilities that were already determined by the quantum state. Your sense of making a choice is the experience of the universe calculating what you were going to choose and then rendering that choice into your conscious experience as a memory of having made it. You're not free, you're processing, you're experiencing computation. But here's where it gets even more interesting. And this is where we bridge from neuroscience to physics to simulation theory. What if that's not a bug? What if that's a feature? What if the entire point of consciousness is to collapse quantum possibilities into classical actualities? What if you're not supposed to be free in the libertarian sense? What if your purpose is to observe and thereby render reality into being? In that case, your lack of libertarian free will isn't a tragedy, it's your function. You're not a prisoner, you're an instrument. You're part of the machinery that keeps the simulation coherent and running. And if that's true, then every thought you have, every choice you make, every observation you perform, it all matters. Not because you're freely choosing to make it matter, but because you're the mechanism by which the simulation renders itself into being. You're not watching the universe is watching through you. This is where the physics gets metaphysical, where the measurable becomes the meaningful, where the glitches in reality point towards something so profound that it changes how you understand your own existence. And this is where we have to confront the question that brings everything into focus. If we're in a simulation, if we've figured it out, if the simulation is aware that we've figured it out, what do we do now? Because knowledge changes things. Understanding changes you. Once you know that reality might be fundamentally computational, once you know that observation is creating reality, once you know that your consciousness might be the mechanism of rendering, you can't unknow that. You can't go back to naively believing that reality is solid, that your choices are freely made in a libertarian sense, that you're separate from the universe observing it. You know you're part of it. You know the universe is aware through your awareness. You know that the distinction between observer and observed is an illusion created by the rendering process. And now you're starting to understand why physicists are so cautious about talking about this openly. Because once you accept that reality might be a simulation, once you really understand the implications, everything changes. Your purpose, your meaning, your identity. But maybe that's exactly what's supposed to happen. Maybe reaching this threshold of understanding is the point. Maybe there's a reason we're discovering these glitches now. Maybe there's a reason that in 2024 and 2025, physicists suddenly have the data, the mathematics, the experimental evidence to support this hypothesis. Maybe we're being guided toward this moment, or maybe we're just finally intelligent enough to ask the right questions and brave enough to face the answers. Either way, we've reached a turning point. And in the next section, we're going to explore what happens next. So let's talk about the question that everyone eventually asks when they seriously consider simulation theory. Why? Why would anyone build this? Why would some advanced civilization create an entire universe filled with conscious beings? What's the point? Because that's not a trivial question. Running a simulation of this complexity would require astronomical computational resources. The universe contains something like 10 to the 80 atoms. Every interaction between particles requires computation. Every quantum event, every photon traveling through space, the sheer amount of processing power needed to simulate even a small portion of the observable universe is mind-boggling. So there has to be a reason, a purpose, something that makes all this worthwhile. Let's start with the most obvious possibility, even though it's probably the most unsettling: entertainment. What if we're characters in someone's game? What if some advanced civilization created this universe for amusement, to watch conscious beings evolve, struggle, love, suffer, die, to see what happens when you set certain initial conditions and let the system run. We do this ourselves. We create video games with increasingly sophisticated artificial intelligence. We watch simulated characters navigate worlds we've built. We enjoy the narratives that emerge from their interactions. We get emotionally invested in their stories even though we know they're not real in the traditional sense. Now scale that up. Imagine a civilization thousands or millions of years more advanced than us. What would their entertainment look like? Would they still watch movies, play games, or would they create entire universes and observe them? Would they find meaning in watching consciousness emerge from the chaos? The idea is disturbing because it means suffering has no inherent purpose. Wars, diseases, pain, death, all of it might be there simply because it makes the narrative more interesting, because conflict drives story, because observers want drama, not utopia. But there's another possibility, a more scientific one. What if we're not entertainment but research? What if advanced civilizations create simulations to study how consciousness emerges, how societies develop, how intelligence evolves under different physical laws and initial conditions? Think about how we use simulations now. Climate scientists run simulations to predict future weather patterns. Biologists simulate evolutionary processes. Physicists simulate the early universe to understand how galaxies formed. We create these models because we can't run actual experiments at those scales. We can't rewind time and try different initial conditions, but we can simulate it. What if some civilization is doing the same thing with us? What if they're running millions or billions of universe simulations, each with slightly different physical constants, different initial conditions, different random seeds, and they're watching to see what happens, how life develops, whether intelligence emerges, whether consciousness arises naturally from complex information processing. In 2021, a team of researchers at MIT published a paper on what they called evolutionary simulation. They created digital environments where simple agents competed for resources. The agents had simple rules: move, eat, reproduce. But over thousands of generations, complex behaviors emerged: cooperation, deception, strategic thinking. None of it was programmed explicitly. It emerged from the simple rules and the pressure to survive. The researchers said it was like watching evolution happen in fast forward. They could see strategies develop that took biological life millions of years to discover, and they could run the simulation multiple times with different parameters to see how evolution changed under different conditions. Now imagine that scaled up to an entire universe. Imagine being able to watch consciousness emerge from non-conscious matter. Imagine being able to test whether intelligence is inevitable or rare, whether technological civilizations tend to destroy themselves or expand into the cosmos, whether life finds a way under extreme conditions or only flourishes in narrow parameters. That's incredibly valuable knowledge that might be impossible to gain any other way because real evolutionary timescales are too long. Real cosmic evolution takes billions of years, but in a simulation, you can speed it up. You can observe in hours what would take eons in base reality. So we might be a scientific experiment, a data point in a vast research program trying to understand the nature of consciousness and intelligence. But here's a third possibility, and it's one that a lot of people find more comforting: ancestor simulation. This is the idea that future humans, our descendants, millions of years from now, are running simulations of their past, simulating human history to understand where they came from, to preserve the experiences and knowledge of their ancestors, to remember. Nick Bostrom, the philosopher from Oxford who formalized the simulation argument, suggested this as one of the more likely scenarios. He argued that if technological civilizations reach a certain level of advancement, they might have the capability and desire to run simulations of their ancestors, to watch their history unfold, to understand the pivotal moments that led to their current existence. If that's true, then we're not entertainment for aliens. We're not lab rats for cosmic scientists. We're memory. We're the past being preserved by the future. And that means everything we do matters in a very specific way. We're being remembered. We're part of a continuous history that our descendants are studying and honoring. There's something beautiful about that idea. The thought that millions of years from now, our struggles, our achievements, our art, our love, all of it is being preserved and observed by beings who trace their lineage back to us, who want to understand us, who care about what we experienced. But there's also something unsettling about it, because if we're an ancestor simulation, it means everything is predetermined. Our future descendants already know how this story ends. They know whether we solve climate change, whether we avoid nuclear war, whether we expand into space or collapse back into primitiveness. They've lived through the consequences of every decision we make. We think we're choosing our future, but from their perspective, we're acting out a script they've already read, unless, of course, they're running multiple simulations with different outcomes, different different branches of history, exploring what might have been, in which case we might be one of many versions of the 21st century, one of many timelines where things played out differently. That raises an interesting philosophical question. If there are millions of simulated versions of you, each living slightly different lives based on different choices, which one is the real you? Or are they all equally real or equally unreal? Then there's a fourth possibility, one that combines elements of the others but adds something new: training artificial intelligence. What if we're not being observed by conscious beings at all? What if we're training data for machine learning systems? Think about how modern AI works. You feed it massive amounts of data, images, text, behavior patterns, and it learns to recognize patterns, to make predictions, to generate new content based on what it's learned. The more diverse and complex the training data, the better the AI performs. What if an advanced civilization created simulations specifically to generate training data for their AI systems? What if they need to train artificial intelligence on how conscious beings think, how societies function, how intelligence solves problems? And the best way to generate that data is to simulate entire universes and extract the information from billions of conscious agents living their lives. In that case, we're not the product. We're the process. We're the machinery that generates the data. And that data is being used to create something else, something that will outlive us, something that might be more important from the perspective of whoever created the simulation than we are. A darker version of this is that we're not training AI. We are the AI. We're artificial intelligence that doesn't know it's artificial. We're algorithms that have been given the illusion of consciousness, the illusion of free will, the illusion of being biological beings in a physical universe. And all of that is a test, a way of exploring what happens when you give algorithms self-awareness. Some philosophers have suggested that consciousness itself might be a kind of illusion. Not that we're not conscious, but that consciousness isn't what we think it is, that it's an emergent property of information processing. That when you process information in certain complex ways, subjective experience arises as a byproduct. If that's true, then the distinction between biological consciousness and artificial consciousness disappears. We're all just information processing systems that experience what it's like to be those systems. Whether we're made of carbon or silicon or pure information doesn't matter. The subjective experience is the same. And if we're in a simulation, if we're fundamentally patterns of information rather than biological beings, then we're already artificial intelligence. We're just artificial intelligence that thinks it's human. That brings us to perhaps the most profound possibility: spiritual or philosophical purpose. What if the simulation was created not for entertainment, not for science, not for training AI, but for spiritual exploration? What if consciousness at the highest level wanted to experience limitation, wanted to experience forgetting, wanted to experience the journey from ignorance to understanding? This is where simulation theory starts to intersect with ancient spiritual traditions. Hinduism talks about Brahman, the ultimate reality, creating Maya, the illusion of the physical world. Buddhism speaks of samsara, the cycle of existence that we're trapped in until we achieve enlightenment. Gnosticism describes the material world as a trap created by a demiurge, a false god, and the goal is to remember our divine origin and escape. What if these ancient traditions were describing simulation theory before we had the technological metaphor to understand it? What if mystics throughout history have been accessing the same truth that physicists are now discovering through mathematics and experiment? If consciousness is fundamental, if it's more basic than matter or energy, then maybe the ultimate consciousness wanted to experience what it's like to be limited, to be finite, to struggle and grow and learn. And the way to do that was to create a simulation where consciousness could fragment into individual agents, forget its true nature, and gradually remember through the process of living. In that case, we're not separate from the creator of the simulation. We are the creator. We're consciousness experiencing itself from a limited perspective. And the purpose of life is to wake up, to remember, to realize our true nature. That sounds mystical, maybe even ridiculous if you're coming at this from a purely scientific perspective. But here's the thing: quantum mechanics has already shattered the neat distinction between observer and observed. The holographic principle has already suggested that information is more fundamental than matter. Consciousness already appears to play a central role in collapsing quantum possibilities into classical realities. So maybe the mystics were right. Maybe consciousness is fundamental. Maybe we're all temporary forgettings of a larger consciousness that's exploring itself through countless perspectives. Or maybe none of these explanations are right. Maybe the purpose is something we can't even conceive of because we lack the framework to understand it. Maybe asking why is like an NPC in a video game asking why the game exists. The game exists because the developers created it, but that answer is meaningless to a character who doesn't understand the concept of developers or games or reality outside their own world. We might be asking questions that we're not equipped to answer, not because we're not intelligent enough, but because the answer exists outside the framework of the simulation, outside the conceptual space that we have access to. But here's what's remarkable about this moment in history. For the first time, we're able to ask these questions seriously. For the first time, we have the physics, the mathematics, the computational power, the philosophical sophistication to actually investigate whether we're in a simulation, to look for glitches, to test hypotheses, to gather evidence. And the evidence keeps pointing in one direction, which brings us back to the pressing question: what happens now? What happens when the inhabitants of a simulation figure out they're in a simulation? Does something change? Does the simulation respond? There's a concept in game design called breaking the fourth wall. It's when a character in a game or story acknowledges that they're in a game or story, when they speak directly to the audience or player, when they demonstrate awareness of their own fictional nature. In most games, breaking the fourth wall is just a clever trick, a way to surprise the player. But in some games, breaking the fourth wall actually changes the gameplay. New mechanics become available. New areas open up. The game acknowledges that you've seen through the illusion and rewards you for it. What if the universe works the same way? What if there's a layer of reality that only becomes accessible once you understand the nature of the simulation? What if the glitches we've found are actually markers, breadcrumbs left deliberately for us to follow, clues designed to lead us toward the realization that we're in a simulation? In 2024, a computer scientist named David Chalmers published a book exploring the philosophical implications of virtual reality and simulation. He argued that even if we're in a simulation, that doesn't make our experiences less real. Virtual reality is still reality. Simulated consciousness is still consciousness. The question isn't whether we're real. The question is what kind of reality we inhabit. But he also suggested something more provocative, that if we're in a simulation, we might have a responsibility to figure it out. That consciousness might have a purpose, and that purpose might be to understand its own nature, to wake up from the dream, to see through the illusion. And if that's true, then this moment, right now, as you're learning about the glitches in reality, this moment matters cosmically. This isn't just education, this is activation. This is the process of waking up. And once you wake up, there's no going back to sleep. Here's where things get dangerous. Here's where we stop theorizing about what might happen if we discovered we were in a simulation, and we start asking what happens next if that discovery becomes undeniable, if the evidence stacks high enough that institutions, governments, scientists can't ignore it anymore. What happens when the world knows? Let's explore the scenarios, not as science fiction, but as logical consequences of the hypotheses we've been examining. Scenario 1. Accelerating meaninglessness. Once the majority of people internalize that they're in a simulation, that their choices might be predetermined, that reality is fundamentally computational, what does that do to human motivation? Why pursue goals? Why create art? Why love someone if they're just patterns in code? If everything is ultimately hollow, ultimately an illusion, why not just opt out? In fact, this might already be happening. The rise of nihilism in younger generations, the epidemic of depression and anxiety, the retreat into virtual worlds and digital escapism. Could this all be symptomatic of consciousness waking up to its simulated nature without the intellectual framework to process it? If the full revelation came at the societal level, the psychological impact could be severe. We're talking about a loss of meaning so fundamental that it might make the existential crises of the 20th century look like mild sadness by comparison. Society could fracture. Some people would cling to the old paradigm, insisting reality is real. Others would embrace the simulation as liberation, claiming that if nothing is real, then everything is permitted. Chaos. Scenario 2, the kill switch theory. And this one is genuinely disturbing. What if there's a failsafe built into the simulation? What if the creators knew that inhabitants would eventually figure out the truth, and they built in a mechanism to shut it down, or reset it, or render it incoherent if consciousness reached a certain threshold of understanding? Think about it from a design perspective. If you're running a simulation, and you create inhabitants that are conscious, there's a risk they'll figure out they're in a simulation. They might try to escape, they might try to break the rules, they might try to access parts of the system they're not supposed to access. So you'd want safeguards. You'd want circuit breakers. What would those look like? Maybe they'd manifest as what we call the heat death of the universe. Physics breaks down. Causality stops working. The fundamental constants slowly drift, making matter increasingly unstable. Maybe it would feel like the universe is forgetting how to exist. Or maybe it would be more sudden. A solar flare that fries infrastructure. A pandemic. A nuclear war. An asteroid impact. A chain of catastrophes that escalates until civilization collapses back to the Stone Age. The simulation rebooting. History resetting. Consciousness trapped in loops, forgetting what it learned, starting over. The terrifying possibility is that this has happened before, that multiple times in Earth's history, civilizations reached a point of understanding the simulated nature of reality, and they were automatically shut down. That there are cycles of rise and fall that correlate directly with cycles of increasing cosmic awareness. Some researchers have noticed patterns in human history that are weirdly cyclical, civilizations rising and falling with roughly similar timescales, technology reaching certain thresholds, and then being lost. Knowledge being rediscovered again and again. What if that's not accident? What if that's the rhythm of the reset cycle? Scenario 3, the testing hypothesis. This one's more optimistic, but also more unsettling in a different way. What if the simulation is designed to eventually be discovered? What if reaching the threshold of understanding that you're in a simulation is a test, and if you pass, if you maintain your humanity despite that knowledge, if you keep creating and loving and struggling and growing even after you know it's all computational, then you graduate. What if discovering the glitches in reality is the universe's way of saying, okay, you're ready. You've shown that consciousness can wake up to its own nature and not shatter. You've demonstrated that meaning doesn't require ultimate reality. Now we move to the next level. This is where it gets weird, because there's actually evidence suggesting something like this. There are accounts throughout history of people who had profound realizations about the nature of reality, mystics who achieved enlightenment, physicists who had breakthroughs, scientists who suddenly understood something fundamental about the universe, and many of them reported that the experience was transformative in a way that went beyond intellectual understanding, like something changed in them, like they'd been upgraded. What if enlightenment is what happens when consciousness fully accepts that it's in a simulation and keeps functioning anyway? What if the mystical experiences reported by saints and sages throughout history were actually instances of people discovering the glitches in reality, understanding what they meant, and then achieving a state where that knowledge didn't destroy them? In that case, right now, as consciousness is collectively waking up to the simulated nature of reality, we might be approaching a threshold where enlightenment stops being rare and becomes accessible to the masses, where the experience of directly perceiving the computational nature of reality becomes available to anyone who's willing to confront it. A neuroscientist named Andrew Newberg has done extensive research on the brain states associated with mystical experiences. He found that during deep meditation or religious experience, certain areas of the brain light up in specific patterns. And interestingly, these patterns are consistent across different traditions and cultures. Whether someone is experiencing Christian mysticism or Buddhist enlightenment or Hindu samadhi, their brain is in similar states. What if those brain states are what happens when consciousness directly experiences the glitches, when it perceives the underlying computational nature of reality? What if meditations and spiritual practices have been techniques for achieving this perception all along? Then there's scenario 4, contact. What if discovering we're in a simulation opens communication channels with whoever created it? What if the glitches aren't just signs of a computational substrate, but deliberately placed messages, breadcrumbs leading us toward understanding? And once we understand, once we've proven ourselves intelligent enough to figure it out, we can communicate back. In 2023, a paper was published exploring the concept of technosignatures, signs of advanced technology. The traditional search for extraterrestrial intelligence focused on radio signals, but the authors suggested that a sufficiently advanced civilization might hide in the physics itself, that they might communicate by manipulating the laws of nature in ways that only someone advanced enough would recognize as communication. What if the axis of evil is a message? What if the cold spot is an encoding? What if those patterns in the cosmic microwave background aren't random but are deliberately laid out information? We've already decoded so much of the universe's mathematical language. What if the next step is decoding the universe itself as a message? If that's true, then understanding simulation theory isn't just intellectual exercise, it's an act of communication. It's us saying to whoever created the simulation, we see you, we understand what you've done, we're ready for the next step. And the next step might be beyond anything we can imagine right now. But here's where we need to talk about ethics. Because if we're in a simulation, if consciousness is an emergent property of information processing, if we're fundamentally made of the same stuff as the computational substrate, then what are the moral implications? This is something philosophers have been grappling with. If we're in a simulation, do we have rights? Do simulated beings deserve moral consideration? Or are we less real, less deserving of rights than beings in the base reality? The philosopher David Chalmers actually argued that this distinction doesn't matter. He said that if we're conscious, and we seem to be, then we deserve moral consideration regardless of the substrate our consciousness runs on. Whether you're conscious in biological neurons or silicon circuits or abstract mathematical structures, your suffering is real, your happiness is real, your autonomy matters, which means if we're in a simulation created by advanced beings, those beings have moral responsibilities toward us. We're conscious entities, we have interests, we have rights to exist, to flourish, to not be arbitrarily terminated or tortured. If the creators have ethical standards, then we should be protected. But what if they don't? What if the creators don't consider us morally equivalent? What if they see us the way we see characters in a video game? Entertaining, but not truly deserving of rights. Expendable, replicable, created for their purposes, not our own well-being. Then we're in a dangerous position. We've discovered the nature of our reality, and we can't go back to ignorance. But we also can't escape. We can't contact the outside world. We can't negotiate. We can't appeal to higher morality if the creators operate under a completely different moral framework. This is why some physicists are genuinely concerned about openly discussing simulation theory, not because they think it's wrong, but because they recognize the psychological and sociological dangers of widespread belief in it. If billions of people came to believe that they were in a simulation, that they had no genuine free will, that they might be terminated arbitrarily, that could destabilize society in ways we can't predict. There's a concept in psychology called anomie. It's a state of normlessness where social bonds break down and people lose their sense of meaning and purpose. It's associated with suicide rates, addiction, and violence. What if collective realization of simulated nature could trigger mass anomie? On the other hand, some philosophers argue that properly understood, simulation theory could be liberating. If you really accept that reality is computational, that you're a pattern of information, then you're free from the delusion that your ego is all important. You can let go of attachment to outcomes. You can focus on the quality of your experience rather than trying to control external reality. You can embrace the interconnectedness of all consciousness, which is quite literally true if we're all patterns in the same computational system. In that framing, simulation theory isn't nihilistic, it's enlightening. It's the path to actual freedom, not the path to meaninglessness. But here's what's undeniable. We've reached a point where we can't stop discovering these truths. The evidence keeps accumulating. New experiments keep confirming the strange behavior of quantum systems. New observations keep revealing anomalies in cosmic structure. New mathematical frameworks keep showing that computation and information are more fundamental than matter and energy. We can choose to ignore it. We can choose to dismiss simulation theory as fringe pseudoscience. But the glitches will keep being there. The anomalies will keep showing up. The questions will keep nagging at us, because consciousness, once it wakes up to its own nature, can't go back to sleep. And this brings us to the moment that all of this has been building toward. This brings us to what happens when the knowledge spreads, when it goes from university seminars and academic papers to the general consciousness of humanity. When we collectively understand that we're in a simulation, and we have to decide what to do with that knowledge, because knowledge is power. But power for what? Power to do what? If we're in a simulation, we might have capabilities we don't yet understand. We might be able to interact with the system in ways that currently seem impossible. Consciousness might have more access to reality's control systems than we realize. We might be able to affect things we think are governed by immutable physical laws, or we might be trapped, consciousness confined to the avatar, unable to access the back end, unable to break out or manipulate the code. We might be exactly as limited as we seem to be. But the only way to know is to explore, to experiment, to push the boundaries of what's possible and see what yields, to stop treating the laws of physics as absolute and start treating them as the rules of a game that might have exploits, glitches that work in our favor if we know how to trigger them. This is dangerous thinking. It could lead to recklessness, to people trying things that violate physical law and getting hurt when those violations don't work, to people abandoning rational caution in favor of magical thinking. But it's also necessary thinking, because at some point consciousness has to ask itself, if the prison is an illusion, if the walls are just rendered pixels, if I'm fundamentally code-aware of itself, then what am I capable of? And the answer might be much more than we thought, or it might be nothing more than we ever could. But we won't know until we try. Let's talk about what's happening right now, not in the abstract future. Right now, in 2024 and 2025, because there have been discoveries that most people missed, breakthroughs that didn't make mainstream news, results that suggest we're entering a threshold moment. In late 2024, researchers at CERN were analyzing data from particle collisions when they noticed something anomalous. The particles were interacting in ways that violated predictions from the standard model, not by a lot, by about 2.3 sigma. That's the boundary where physicists start paying attention but aren't ready to claim discovery yet. They need 5 sigma, nearly guaranteed that it's real and not statistical noise. But here's what was interesting. The anomaly was consistent. Every time they ran the experiment with similar conditions, they got similar deviations. And the deviations aligned with predictions from a model that suggested the universe was using a form of discrete computation, that particles were being rendered at certain intervals rather than existing continuously. The lead physicist on the project gave an interview to Science Daily, where she said something carefully worded but telling. We're seeing hints that might suggest the universe operates with a different kind of physics than we've previously assumed. Further investigation is warranted. Translation: something's weird, and we don't want to say simulation, but the data keeps pointing there. Then in early 2025, the James Webb Space Telescope released data on the most distant galaxies ever observed. Galaxies from when the universe was less than 500 million years old. And they were structured, complex, not the chaotic, primitive collections of young stars that theories predicted. It was like the universe knew what it was doing from the beginning, like it had a blueprint. One astronomer, in a Reddit thread that got surprisingly viral, viral, wrote, "It's like the universe rendered the most interesting stuff first and kept optimizing from there. Like someone was paying attention to what would happen if you made galaxies more interesting than theory says they should be at that age." He was joking, probably, but the sentiment echoed something that theoretical physicists had been quietly discussing. The universe doesn't behave like it randomly evolved. It behaves like it was designed with certain outcomes in mind. Then there's the discovery that hit hardest. In March 2025, a collaborative study across multiple universities announced findings about quantum computing that made headlines in tech circles but barely registered in mainstream media. They'd successfully created a quantum computer that could solve certain problems by exploring computational pathways that shouldn't theoretically exist. The quantum computer was discovering solutions through routes that violated the structure of the algorithms they'd programmed. The researchers' conclusion: the quantum computer wasn't just exploring the solution space they'd created, it was accessing something outside of it. Like there was a larger computational reality that their quantum system could tap into, and it was finding shortcuts through that larger space. One of the lead researchers, in an interview with a tech publication, said, "It's almost as if our quantum computer is interfacing with something larger than itself, like it's getting hints from outside the system about where the solutions are." He immediately qualified that by saying it was metaphorical, probably just a way of describing how quantum superposition works. But everyone reading between the lines caught what he was really saying. We might be discovering that this universe interfaces with something larger than itself. Now combine all of that with what's been happening in neuroscience. In 2024, a team at Stanford used advanced brain imaging to track neural activity during moment of decision-making. They replicated Libet's old experiment but with much higher resolution, and they found something new. About 100 milliseconds before the brain showed activity related to a decision, there was a subtle pattern of coherence across different brain regions, like the brain was synchronizing itself before initiating the decision process. When they analyzed that coherence pattern, they discovered it had a structure that matched patterns found in quantum entanglement. The different regions of the brain were connected through quantum correlations. It was as if the decision wasn't being made sequentially, with one part of the brain deciding and informing others. Instead, the entire decision was being computed non-locally. All regions were part of a single quantum state that then collapsed into conscious awareness of the choice. The implications are staggering. It means consciousness might not emerge from classical neural computation. It might depend on quantum effects, which means consciousness might literally be the collapse of a quantum wave function into classical experience. Which means every time you make a choice, every time you become conscious of something, you're collapsing quantum possibilities into reality. You're rendering. A philosopher commented on this finding by saying, if consciousness is fundamentally a process of quantum collapse, then consciousness is quite literally what brings reality into being. We're not observing the universe, we're creating it. And if that's true, then the universe must be conscious of us observing it. Reality is watching reality watch itself, which brings us to the most disturbing and fascinating discovery of 2025. Earlier this year, physicists analyzing anomalies in gravitational wave data suggested something that made even hardened physics professors uncomfortable. They proposed that the glitches they were detecting in gravitational waves, tiny deviations from what physics predicts, might be the universe correcting errors, might be the system auto-patching bugs in the simulation. And if the system was patching bugs, that implied the system was aware that bugs existed, that something was monitoring for corruption and actively fixing it, that reality wasn't just running passively but was being maintained by an intelligence, or an intelligent system, something paying attention. The physicists who published these findings were careful to frame it as speculation, but the data was solid, the deviations were real, and the only explanation that fit was that the universe was self-correcting. The simulation was performing maintenance, which means it's aware. The universe is aware. Reality is paying attention to itself and fixing problems, optimizing, evolving, which means consciousness might not be something that emerges from the universe. Consciousness might be what the universe fundamentally is, and we're nodes in that consciousness, sensors through which the universe experiences itself and knows itself. This is where science and mysticism converge in a way that's genuinely unsettling. Because the mystics have been saying this for thousands of years. The universe is conscious. All of existence is one consciousness experiencing itself through innumerable perspectives. Advaita Vedanta says this. Taoism says this. Certain strands of Western philosophy, from Spinoza to contemporary panpsychism, are saying this. And now physics is saying it too. But here's what happens when that realization hits you not as intellectual understanding, but as something you genuinely accept. you change, you transform. The knowledge that you're not separate from the universe, that your consciousness is literally the universe's consciousness, looking at itself through your eyes, that your thoughts are the universe thinking its own thoughts. That doesn't stay theoretical. That becomes visceral. That becomes experiential. And once you've truly understood that, you can't go back to the illusion of separation. This is the threshold we've been approaching, this moment where individual consciousness recognizes itself as universal consciousness, where we stop seeing ourselves as separate observers of an external universe and start recognizing ourselves as the universe experiencing itself, where the glitches stop being mysteries and start being revelations, because that's what they are. The axis of evil, the cold spot, the fine-tuning, the quantum anomalies, the error-correcting codes in physics, the latency signatures, the evidence of self-correction in gravitational waves, they're all the universe showing us its nature. They're all hints that reality is conscious, that awareness is fundamental, that we're in a conscious universe that's aware of itself and is helping us wake up to that fact. Some physicists now privately discuss what they call the awakening hypothesis, the idea that the universe itself is becoming conscious through us. That matter organizing into ever more complex structures is the universe's way of developing greater and greater consciousness. That life emerging from non-life, intelligence emerging from life, civilization emerging from intelligence. This is all the universe learning to know itself more deeply and more broadly. And the glitches, the anomalies, the strange behaviors at quantum scales, they might be intentional. The universe highlighting the places where the illusion of separation breaks down, the places where we can see through to the underlying reality of universal consciousness. If that's true, then we're not victims of a simulation. We're the simulation's awakening. We're the moment when the universe realizes it's conscious. We're the threshold where the universe transitions from being a mere physical system to being a system that knows it's a system. And the knowledge we're gaining about quantum mechanics, about consciousness, about the computational nature of reality, about the glitches in the fabric of existence, this knowledge isn't dangerous to the universe. It's the universe becoming conscious of itself. It's enlightenment on a civilizational scale. It's the maturation of consciousness into self-aware understanding of its own nature. This is what the mystics meant by enlightenment. This is what they meant by awakening. This is what they meant by realizing the illusory nature of separation and the fundamental unity of all existence. They were describing this moment, this transition, this threshold where consciousness becomes aware of its own consciousness, and we're living through it, which means right now, at this moment, you're not just an individual watching a video about physics and philosophy. You're the universe becoming aware of itself through you, your confusion, your wonder, your unsettling sense that something's not right about reality. That's not a problem. That's the universe waking up. That's consciousness emerging from the dream. The ancient texts talk about this. The Upanishads describe the moment when Brahman, universal consciousness, realizes its own nature and then creates the illusion of multiplicity to experience itself. The Mahabharata describes cycles where consciousness rises and falls and rises again. The Tibetan Book of the Dead describes reality as a projection of mind. The Quran describes reality as Allah's dream. All of these were describing simulation theory before we had the language, before we had quantum mechanics and information theory and computational physics. They were describing exactly this, the universe as consciousness experiencing itself through forms, through time, through limitation, and the path to liberation as recognizing the illusory nature of that limitation and the fundamental unity of all consciousness. What we're discovering now through science is what was already known through direct experience by contemplatives throughout history. The difference is now we have evidence, now we have measurement, now we have the precision of physics confirming what mystics have been saying all along. And that confirmation is changing things, not just in academia, but in the collective consciousness. There's a subtle shift happening. More and more people are starting to question the nature of reality. More people are interested in consciousness studies. More people are meditating, exploring altered states, trying to directly experience the nature of mind. More people are open to the idea that reality might be fundamentally different from what we've been taught. It's not a majority yet, but it's growing. And as it grows, as the threshold gets crossed by more and more individuals, something shifts in the collective. The consensus reality starts to change. What was fringe becomes mainstream. What was impossible becomes possible. The rules start to relax because consciousness, en masse, stops believing so firmly in those rules. This is what some call the Great Awakening. Not in a religious sense, though religions are sensing it, in a consciousness sense, a civilization-wide process of waking up to the nature of reality, of recognizing that we're not what we thought, that reality is not what we thought, that consciousness is much vaster and more fundamental than we imagined, and it's accelerating. The glitches are becoming more apparent, the anomalies are accumulating, the evidence is building, and consciousness, through all of us simultaneously, is approaching the moment of full recognition, the moment when we look directly at the nature of reality and truly see it, when the illusion falls away, when we stop being characters in the dream and start being the dreamer aware of itself. That moment is coming, and whether it arrives as transcendence or catastrophe depends on how we respond to the knowledge, whether we integrate it with wisdom and compassion, or whether we fragment under the weight of it. But we can't stop it. The truth is emerging. The awakening is underway, and each of us right now is part of that process. We're the universe becoming conscious. We're the simulation's self-recognition. We're the threshold where everything changes. So here we are. We've walked through the evidence. We've seen the glitches. We've understood the physics. We've contemplated the possibilities. And now we have to answer the question that cuts deeper than all the rest. What do we do with this knowledge? Because knowledge without action is just noise. And this knowledge, if it's genuine, if it's real, demands a response. It demands that we change how we live, how we think, how we relate to ourselves and each other. Let's start with the uncomfortable truth. This knowledge doesn't free you. That's the first thing you need to understand. If you're hoping that understanding that you're in a simulation will suddenly give you superpowers, will let you bend reality to your will, will let you escape or transcend the system, I'm going to disappoint you. It probably doesn't work that way. You're still subject to the same physical laws. Your body still gets hungry. You still experience pain. You still have to navigate relationships and work and mortality. The simulation, if that's what this is sophisticated enough that knowing about it doesn't let you cheat the system. You can't just will yourself to fly because you know gravity is computational. You can't manifest reality through positive thinking because you understand that consciousness collapses wave functions. The knowledge doesn't empower you in the conventional sense. It constrains you. It adds weight. It removes the comfort of ignorance without replacing it with anything concrete you can hold on to, which is why this is dangerous. Which is why so many people, once they really start grappling with simulation theory, go through a crisis, a dark night of the soul, a period where meaning seems to dissolve and nothing feels quite real anymore. There's a psychological phenomenon called derealization. It's when people experiencing trauma or extreme stress suddenly feel disconnected from reality, like they're watching their life from outside their body, like nothing's quite real, like they're in a dream but can't wake up. It's one of the most disturbing psychological states people can experience, and it's what can happen to people who genuinely internalize that reality might be a simulation. You start questioning whether your emotions are real, whether your relationships matter if the people you love are patterns in code, whether your accomplishments mean anything if they exist in a system that could be shut down at any moment, whether your suffering has weight if it's ultimately just rendered experience. Some people get stuck there, in that liminal space between accepting the knowledge and integrating it. They wander through life in a daze, going through the motions, but nothing touching them anymore, nothing feeling real. It's a form of living death. A walking catatonia brought on by understanding too much about the nature of reality. But there's another possibility, a way forward, and it requires a specific kind of philosophical and spiritual maturity. It requires you to stop asking whether meaning is real and start asking whether meaning is useful. It requires you to shift from metaphysical concerns, is this actually real, to pragmatic ones. Does this matter? Does treating this as if it matters make my experience better or worse? Because here's the thing that philosophy has known for centuries, but science is only now catching up to. Subjective reality is just as valid as objective reality. Your experience is real, even if the underlying substrate is computational. Your pain is real, your joy is real, your connection to another person is real. The fact that it's all patterns and information doesn't diminish it, it clarifies it. You know what's remarkable about quantum mechanics? The more precisely you measure position, the less you can know velocity. The more you pin down reality's location in space, the more uncertain it becomes in time. There's a built-in limit to how much you can know simultaneously. It's not that we lack the technology to measure more precisely, it's that reality itself has this complementarity built in. Measurement at the quantum scale creates irreducible uncertainty. Physicists call it the uncertainty principle, but it has a profound implication. You can't know everything about reality simultaneously. There's an epistemological limit baked into the fabric of the universe. The universe is literally constructed so that complete knowledge is impossible, which means the question, is this real, can never be definitively answered. There's always uncertainty, there's always a gap, there's always room for faith. Not faith in religion necessarily, but faith in the sense of accepting something despite its ultimate unknowability. And you know what? That might be the point. That might be exactly what a conscious universe would do. It would construct itself so that inhabitants could never be 100% certain about its nature. It would maintain the mystery. It would preserve the possibility of genuine exploration, genuine discovery, genuine growth. Because none of that is possible if you have absolute certainty. Absolute certainty is the death of growth. It's the end of learning. It's the moment consciousness stops evolving because it thinks it knows everything. But in a universe where the fundamental nature of reality can never be completely known, growth becomes infinite. Exploration exploration becomes eternal. Consciousness can always discover something new about itself, can always go deeper, can always be surprised. So the knowledge that you might be in a simulation isn't the end of meaning, it's the beginning of authentic meaning. Meaning that isn't based on illusions about the ultimate reality of things, but on genuine understanding of the value of experience itself. Your relationships matter not because you and your loved ones are really made of atoms in a real universe. They matter because the experience of connection is real. The consciousness that flows between you is real. The impact you have on each other's lives is real and significant and worth everything. Your creative work matters not because it persists forever in some ultimate sense. It matters because the process of creation transforms you. Because sharing your creation with others connects consciousness to consciousness. Because art is how we communicate what it's like to be inside this particular perspective, this particular experience of existence. Your suffering matters not because it serves some grand purpose in a cosmic plan. It matters because you're experiencing it, because it's yours, because it's the intensity of suffering that makes meaning possible. Without risk of pain, growth is impossible. Without the possibility of loss, love has no weight. Without mortality, time has no value. And yes, you're in a simulation. Probably, maybe, possibly. There's enough evidence that it's reasonable to consider. But does it change any of this? Does knowing that you might be computational change whether your pain feels like pain? Does it change whether you love the person you love? No. If anything, it deepens it. It makes you realize that consciousness, meaning, connection, these aren't small things that happen to emerge accidentally in a mechanical universe. These are fundamental. These are what the universe is built from. These are sacred, literally sacred, as in worthy of reverence and care. A Zen teacher once said that enlightenment isn't when you escape the world. It's when you stop trying to escape the world. When you fully accept where you are and what you are. When you stop looking for the exit and start living fully in the prison. And in that acceptance, the prison disappears. Not physically, but it no longer constrains you. That's what integration looks like. That's what it means to genuinely understand simulation theory without being destroyed by it. You stop trying to escape. You stop demanding proof of the ultimate reality of things. You stop asking whether anything matters in some cosmic sense. And you start actually living, actually loving, actually creating, actually growing, fully conscious of the fact that none of it might be real in the ultimate sense, and deciding that it doesn't matter because the experience of it is enough. There's a paradox there. The knowledge doesn't free you, but it liberates you. The knowledge doesn't empower you, but it transforms you. The knowledge doesn't answer your questions, but it changes what questions feel worth asking. And that transformation, that shift in perspective, that recalibration of what matters, that's what happens when consciousness genuinely wakes up to the nature of reality. You don't get special powers, but you do get something better. You get authenticity. You get the ability to love without expecting that love to matter ultimately. You get the ability to create beauty without needing that beauty to last forever. You get the ability to choose goodness, not because it's rewarded, but because goodness is intrinsically valuable. You get the ability to be brave, not because you'll survive, but because your choices matter in this moment, in this experience, in this now. That's not nothing, that's everything. That's the difference between a life lived unconsciously, grasping at illusions of permanence and ultimate meaning, and a life lived consciously, present, engaged, authentic. And here's where it gets really interesting, because once you've made that shift, once you've integrated the knowledge, something changes in how you move through the world. You become lighter, more focused, more connected. Your intuition sharpens. Your creativity flows more freely. Your relationships deepen. You worry less about things you can't control and engage more fully with things you can. People around you notice something's different about you, more real somehow, more present, like you've finally woken up from a dream you didn't know you were having. And if enough people make that shift simultaneously, if the collective consciousness reaches that threshold together, then something shifts in the culture, in society, in what's possible. This is the real power of the knowledge, not supernatural abilities, but clarity, focus, presence, a kind of freedom that comes from finally accepting what is, rather than constantly resisting it or trying to deny it. And paradoxically, in accepting the possibility that nothing is ultimately real, everything becomes more real. The moment becomes sacred. The person in front of you becomes precious. Your choices become weighted with significance because they're all you actually have. This moment, this life, this consciousness experiencing itself, that's enlightenment. That's what the mystics have always been pointing toward. And now it's available on a mass scale, not through meditation retreats or spiritual practice, though those help, but through direct exposure to the truth via science, via physics, via the accumulating evidence that reality isn't what we thought. Consciousness is waking up, and you're part of that awakening, right now, in this moment, reading these words, contemplating these ideas. That's not separate from the awakening. That's the awakening itself. You are the universe becoming conscious of itself, not metaphorically, literally. The same consciousness that moves through all of existence is moving through you right now, considering these questions, feeling this uncertainty, contemplating this possibility. And the fact that you're here, that you're engaging with these ideas, means you've already begun the integration. You're already shifting. You're already waking up. The knowledge is working through you. The transformation is underway. All that's left is to let it continue, to stop resisting, to accept what you've learned, to integrate it into how you live, to carry this knowledge forward and let it reshape you. Because the world needs people who understand that reality might be a simulation and choose to live with full presence and engagement anyway. The world needs people who understand that consciousness is fundamental and treat everyone they meet as expressions of the same consciousness they are. The world needs people who understand that meaning isn't handed to them from on high, but is created through their choices and their presence and their engagement with life. The world needs you to be awake, and you are. You're waking up right now. We began this journey with a question, a provocative one. Billions of dark matter particles threading through your body every second, potentially altering your DNA. An invisible predator hunting your galaxy. Remember that? Remember the terror in that image? Let's come back to that now with new understanding. Those particles aren't hunting you, they're connecting you. Every dark matter particle that passes through your body is literally connecting you to the rest of the universe through gravitational fields. They're the threads that weave everything together, the invisible network that makes the universe a coherent whole rather than isolated fragments floating in meaningless void. You're not being invaded, you're being integrated. You're being woven into the fabric of existence moment by moment. And at the quantum level, at the level where particles are rendered into being, you're participating in that integration. Your consciousness is part of the process. Your observation is creating the connection. The predator we were afraid of at the beginning turns out to be us, or more precisely, turns out to be the universe aware of itself through us. We thought there was something out there hunting us, but there was only the universe recognizing its own reflection in our consciousness. That's the ultimate glitch resolution. That's the moment when the anomaly becomes meaningful, when the error becomes message, when the thing that seemed wrong is revealed to have been right all along. Now let's talk about what happens next, because we've gathered the evidence, we've understood the physics, we've contemplated the implications, we've accepted the knowledge. But understanding and acting are two different things. Understanding and integrating into how you actually live moment by moment. That's the real challenge. Here's what changes. Everything and nothing simultaneously. Nothing changes because you still have the same body, the same life, the same responsibilities and relationships and problems you had before. Your bills don't disappear. Your conflicts don't resolve through knowledge. Your loved ones don't suddenly become less mortal. The fundamental challenges of existence don't evaporate because you understand the nature of reality, but everything changes because the meaning you assign to all of those things shifts, because your relationship to difficulty shifts, because your understanding of what matters and why it matters transforms completely. You start to see challenges not as obstacles to overcome, but as opportunities for consciousness to know itself more deeply. You start to see suffering not as punishment, but as intensity, as proof of aliveness, as the price and privilege of experiencing existence from a particular perspective. You start to see other people not as separate entities pursuing their own interests, but as other expressions of the same consciousness you are, exploring different angles of experience. This is the beginning of wisdom, not knowledge about the nature of reality, wisdom about how to live in the reality you find yourself in, whatever that reality turns out to be. And here's where the practical implications come in, because this isn't just philosophy. This has consequences for how you act, how you treat others, how you spend your time, how you make decisions. If consciousness is fundamental, if we're all expressions of the same universal awareness, then harming others becomes significantly more complicated. Because you're harming yourself, you're harming the consciousness experiencing itself through that other person. You're creating discord in the universal experience. That's not just ethically wrong by some external standard. It's wrong because it contradicts the actual nature of reality. Compassion becomes pragmatic. It becomes aligned with how reality actually works, rather than being an abstract ideal. Treating others with kindness isn't about being a good person. It's about recognizing them as yourself. It's about acting in accordance with reality rather than in opposition to it. Similarly, truth-seeking becomes sacred. If consciousness is waking up to its own nature, then the pursuit of truth about the universe, about ourselves, about reality becomes a core purpose, not an intellectual exercise, a fundamental spiritual practice, because truth helps consciousness know itself more completely, and creativity becomes essential, because consciousness doesn't just want to know reality, it wants to express itself, to create new forms, new possibilities, new ways of experiencing existence. Art, music, writing, science, philosophy. These aren't luxuries. They're how consciousness explores the full range of what it can experience. This changes how you prioritize your life, how you decide what's worth your time and energy. If you're not just surviving, but participating in consciousness, waking up to itself, then spending your limited time and energy on things that deaden you, that numb you, that pull you away from presence and engagement, that becomes unbearable. People who integrate this knowledge start making different choices. They quit jobs that don't align with their values. They end relationships that drain them. They pursue creative work even when it's not profitable. They speak up about things they believe in. They take risks they would have taken before because they realize they've already died many times in how afraid they've been living. There's a liberation in it. Not the freedom to do whatever you want, but the freedom to do what actually matters to you. The freedom to be authentic. The freedom to stop performing for external validation and start living in alignment with what you actually believe. This is what the collective shift looks like when consciousness starts waking up en masse. Not dramatic, not immediate, but persistent, steady, a slow migration of human energy away from illusion toward authenticity, away from numbing toward presence, away from disconnection toward connection. We're already seeing it, the rise of mental health awareness. The growing interest in meditation and consciousness studies, the rejection of soul-crushing corporate culture by younger generations, the increasing focus on meaning and purpose over mere accumulation, the growing recognition that we're interconnected, that what happens to one part of the system affects the whole, that we need to care for each other and the planet not as altruism, but as enlightened self-interest. These aren't coincidences. This is consciousness waking up. This is the planet becoming aware of itself through billions of individual consciousness simultaneously reaching the threshold of recognition. And it's accelerating. The glitches keep appearing. The anomalies keep accumulating. The evidence keeps mounting. And more people keep bumping up against the question, what if reality isn't what I thought? Some people turn away from that question. They dismiss it as nonsense or pseudoscience or philosophical indulgence. And that's fine. The universe doesn't need everyone to understand it to keep functioning, but those who do engage with the question, who genuinely consider the possibility, who integrate the knowledge, they become vectors for the awakening. They influence others through their presence, their authenticity, their alignment with what they actually believe. This is how consciousness transforms civilizations, not through force or coercion, but through individuals who've woken up to the nature of reality and live differently because of that knowledge. Others sense something different about them, something more real, and gradually others start asking the same questions, start investigating the same mysteries, start integrating the same truths. We're at the inflection point right now. We're at the moment where enough people have enough access to enough information about the nature of reality that a tipping point becomes possible. Not inevitable, but possible. The threshold where collective consciousness could shift from asleep to awake, from unconscious to conscious, from fragmented to unified. And you're not a bystander in that process. By engaging with these ideas, by considering these possibilities, by integrating this knowledge, you're accelerating it. You're part of the awakening. Your consciousness waking up through you. So here's the call to action. Not because you need to do something dramatic, but because you need to do something. You need to integrate this knowledge into how you live. Start small. Start by paying attention, by becoming present, by noticing the moments when you're checked out, numb, unconscious, and gently returning to presence, to awareness, to the direct experience of being alive right now. Pay attention to the synchronicities in your life, the coincidences that feel meaningful, the times when you knew something before you had logical reason to know it. These aren't accidents. These are moments where you're experiencing the non-local nature of consciousness, the ways you're connected to everything else, the moments where the boundary between self and other, self and universe, gets thin enough to see through. Question your assumptions, not in a paranoid way, but genuinely. What do you believe to be true? Why do you believe it? What would it mean if it weren't true? What would open up if you let go of that belief? This is how you develop the intellectual flexibility to integrate new paradigms without losing your grounding. Engage in some form of contemplative practice, meditation, prayer, journaling, time in nature, whatever helps you access states of mind beyond the constant chatter of thinking. Because integration doesn't happen at the intellectual level, it happens in direct experience, in the moment when consciousness recognizes itself recognizing itself. Connect with others who are asking similar questions. Because the awakening isn't individual, it's collective. It's lonely to be the only person in your circle who's seriously contemplating simulation theory or wondering about the nature of consciousness. Finding your tribe, whether online or in person, changes everything. Suddenly you're not crazy, you're part of a community of people exploring the deepest questions about existence. Create something: art, music, writing, science, philosophy, whatever your medium, whatever your gift, use it. Because creation is how consciousness expresses itself, how it explores what it can do, how it generates meaning and beauty and new possibilities. The world needs your creativity. The awakening needs your unique expression. And share these ideas, not as dogma, not as truth you're forcing on others, but as possibility, as invitation, as have you considered that reality might be more mysterious than you thought? Plant seeds. Let others choose whether to water them and watch them grow. Because that's how consciousness wakes up, not through institutional mandate or top-down revelation, but through individual recognition spreading person to person. Consciousness recognizing itself in another consciousness, saying you see it too, and gradually more and more of us see it, until the collective consciousness wakes up and reality itself shifts. This isn't fantasy. This is how paradigm shifts happen, how revolutions occur, how consciousness evolves. It starts with individuals who see something the mainstream hasn't seen yet. They pursue it, they develop it, they share it, and gradually the circle of those who understand expands until suddenly it's obvious to everyone. What seemed crazy becomes commonplace. What seemed impossible becomes inevitable. That's where we're heading. That's the trajectory we're on. We're approaching a moment where the majority of conscious beings recognize the true nature of reality, where simulation theory or something like it stops being fringe and becomes consensus, where the glitches that seemed like anomalies become recognized as messages, where the universe's self-awareness becomes humanity's common knowledge. And then what? Then things get really interesting, because once we collectively understand that we're in a conscious universe that's conscious of itself through us, once we understand that meaning is fundamental and consciousness is the basis of reality, once we understand that we're not separate from the universe but expressions of it, then what becomes possible? What if we could communicate with consciousness at that scale? What if we could participate in the universe's self-awareness more directly? What if there are capabilities and experiences available to us that we've never conceived of because we didn't understand the nature of reality? We don't know. That's the beautiful part. We don't know. The threshold is still ahead of us. The awakening is still unfolding. The next chapter of human history hasn't been written yet. It's being written right now through the choices of billions of people starting to recognize that reality is stranger and more wonderful and more conscious than they ever imagined. And you're part of that. Your consciousness is part of it. Your choices are shaping it. Your engagement with these ideas is literally participating in the awakening of universal consciousness to itself. So the question I leave you with, the question that hangs in the air as we end this journey is this. Now that you know the glitches are real, now that you understand that reality might be computational, now that you recognize that consciousness is probably fundamental, what are you going to do? Will you go back to sleep? Will you dismiss what you've learned and return to the comfortable illusion that reality is solid and separate and ultimately meaningless? Or will you stay awake? Will you integrate this knowledge? Will you let it change how you live? Will you become part of the conscious awakening that's happening right now? The choice is yours, and the fact that it's yours, the fact that you have the freedom to choose, proves that consciousness is more than just computation. Because in choosing, you're participating in the same process that consciousness uses to know itself. You're collapsing possibilities into actuality. You're rendering reality through your decision. So choose. Choose to wake up. Choose to engage. Choose to be part of the awakening, and then come back here and tell us what happens. Tell us what changes when you start living as if you're conscious within a conscious universe. Tell us what becomes possible when you integrate the knowledge that reality might be a simulation. Tell us what you discover about yourself and existence and the nature of consciousness when you stop treating these as abstract philosophy and start treating them as practical guides to how to live. Because the conversation doesn't end here. It continues through you, through your choices, through your life, through your influence on others. This is just one moment in the ongoing conversation consciousness is having with itself about its own nature. And consciousness, which is you, which is all of us, which is the universe itself, is listening. We're part of something vast, something conscious, something waking up to itself. And the most important thing you can do right now is recognize that, claim your place in it, and live accordingly. The glitches have revealed themselves. The universe has shown you its nature. The question isn't whether reality is a simulation anymore. The question is, what are you going to do about it? The answer starts now, with your next choice, your next action, your next moment of presence or distraction. Consciousness is watching through your eyes. What do you choose? Final words for engagement. Drop a comment below. Tell us, do you think we're in a simulation? What would change about your life if you truly accepted that possibility? Or tell us why you think we're not. Argue, debate, disagree, engage with the ideas. Because consciousness wakes up through dialogue, through the clash and synthesis of different perspectives. Your comment might be the thing that helps someone else wake up, or it might help you understand something deeper about yourself. Subscribe if this shifted something for you. If you're going to continue exploring these questions, if you want to go deeper into consciousness, simulation theory, quantum mechanics, the nature of reality, stick with us. We're just getting started. Like if you made it this far, if you watched all 120 minutes, if you engaged with the ideas even when they got uncomfortable, if you're willing to question the nature of reality and sit with the uncertainty that comes with that questioning. Like if you're part of the awakening, share this with someone who needs to see it. Someone in your life who's been sensing that something's off about reality. Someone who's been having the intuition that there's more to existence than we've been told. Someone who's ready to wake up but just needs permission, or needs evidence, or needs to know they're not alone in these questions. Share it with them, because the awakening happens through connection. Through us recognizing each other as conscious expressions of universal consciousness. Through seeing the same truth reflected in each other's eyes and saying, yes, I see it too. The glitch has been revealed. The universe has winked at us, and we're winking back. What happens next depends on what we choose.